Welcome back, everyone. We are going to finish chapter 1 with section 1.8. Before I get to the notes, I wanted to kind of review logarithms a little bit before we get into this. And the first thing with logarithms that we need to review is if we have y equals a to the x power, then this is what's called exponential form. Versus our logarithmic form. You can see everything's been kind of rearranged, not necessarily in an easy to understand way, but it's going to take a lot of practice to get used to this. And this is referred to as logarithmic form. And logarithms and exponential functions are related. They are inverses of one another, meaning if you composite the two, they cancel each other out. So for example, if I have log base a of a to the x power, because I have an exponential inside of a logarithm, they actually cancel each other out. I just get x back. Same here. If I have a to the log base a of x, once again, they cancel one another out. And this will be particularly useful when eventually we get to word problems that have this in there. We have three basic changing rules. I'm not sure what the right vocabulary here is, but we're going to have log base a of x times y, log base a of x plus log base a of y. I call these transformation rules, but I'm not sure that that's the right word either. Log base a of x over y. So when we're multiplying, that becomes addition. And when we're dividing, the denominator becomes the subtract. And our last transformation rule if we have an exponent in the domain, meaning x to the b power in that case, that exponent can come down in front and become multiply. And that will be very, very important as we move through this. A couple of other rules I want to point out is x equals y if and only if log base a of x equals log base a of y, meaning I can apply the log to both ways, or go the other way. If I have the log equals log, then the two domain parts are equal to one another. So the IFF might be new for you. That means if and only if. That's an if-then statement both ways. Usually if-then statements only go in one direction. Our if-then statements, or if and only if statements go in both directions. When someone's doing a proof of these, and if and only if, you have to prove both directions, actually. Here's another if and only if statement. Which are very useful. We also have change of base. Meaning if we have a base that we can't use because our calculators maybe only do base E or base 10, then we can change the base to make it one of those so that we can actually calculate it out. So log base A of x is going to equal log base B, a new base of x, over log base B of A. And usually base B is going to be, like I said, E or 10. And I'd like to define the common log. So log base 10 of x, we never write the 10 in, it's just log of x. So when that base is missing like that, it's an assumed 10. The natural log is log base E of x and we write that as ln of x. Now the E of interest is above my ln button. Now, if you look at the button just to the left of my number 4 button on my calculator, it says ln, and above it, it has the e to the x. So I wanted to hit second e to the x and show you what that number is. So it's a number between 2.7 and 2.8. It's an irrational number, a transcendental, just like pi, meaning even though it looks like there kind of is a pattern, there actually is no pattern, and it cannot be written as a fraction. So here's our review for logarithms. Let's jump into our actual lesson. Here's our section 1.8. And what we're going to do is write the equation in exponential form. So if you look back at your notes, exponential form is when we have a number raised to a power. And in this case, notice that the base is missing in this case. That means it's assumed to be a 10. So to transform this, this is going to be r equals 10 to the y power. By the way, you could write it 10 to the y equals r. That's the exact same answer. There is no difference as far as we're concerned. It'll depend on the problem. One might be more useful than the other. Now we're going to go the other way. We're going to write the equation in logarithmic form. This means that u is equal to log base 10 of t, but I mentioned before, we don't write the 10 in there. So this should just be u equals the common log of t, and we skip the 10. And you might be asking yourself, will I get marked off if I put the 10? I would if I were your teacher. I don't know if my open math does or not. So maybe not risk it and just try to not put it. All right, so if you go back to one of the rules, I think the third rule down, second or third rule down, it says if we have log base a of a to the x, the log base a and the a to the cancel each other out, and we just end up with x. And I want to point out that this is the common log. They're writing the 10 in. I just said that they never do that, but apparently they're doing it here. And this is 10 to the 4th power, and you can see the bases match. So my answer is just 4. All right, next up, question 4. We're going to use our change of base formula if you want to go take a look at that. This is, we don't need to use change of base. We can just use, oh, this is the common log. So we can just literally use our calculator. So I'm going to go to the log button that's right next to my 7, to the left of my 7, my log button. That's the common log of 440. This is about 2.643-ish. So it's round to 3 decimal places. All right, now equation 5, or question 5, notice that the 6 to the x, I can't match that up with 50, meaning I can't make 50 turn into 6 to a power. So what I'm going to do is I'm going to apply one of the rules that I talked about before. I'm going to go ahead and take the logarithm. I'm going to take the natural log of both sides. So I get the natural log of 6 to the x equals the natural log of 50. And I'm going to use our third transformation rule, and I'm going to bring that x down. And now I want to solve for x by dividing both sides by natural log of 6. So I'll bring this over here. I'm going to get that x equals natural log of 50 divided by the natural log of 6. This is going to be about 2.1833. Moving on. Question 6. if e to the 6x equals 15, well, what I'm going to do is I'm going to go ahead and apply the ln to both sides. Ln. So that's going to give me ln of e to the 6x equals ln of 15. Now, if you remember, ln means that it's base e. So I have log base e of e to a power. And remember, our rule says that those just cancel out. So x is going to equal ln of 15 divided by 6. Be sure to close your parentheses when you're doing this. So this is about all right. And our last problem is going to be find the domain. Now, the domain is going to be this part. The 6 minus x. Now, that part has to be positive. Let me show you. If I take the log of -7, it says, hey, don't do that. Now, your error message is very possibly going to look a little bit different than mine, but you should be getting an error message. I can't even take the log of 0. It says don't do that either. So I know that the log of whatever 6 minus x has to be positive, bigger than 0. And remember, when you divide by negative, that changes the direction of the inequality. So x has to be less than 6. As long as x is less than 6, we can dump values of x in there, no problem. And that is going to do it for chapter 1. Thank you very much.